You press the power button on a laptop, and absolutely nothing happens. No lights, no fan spin, no sign of life. It's completely dead. Motherboard power delivery follows a strict chain of events. One specific voltage state physically triggers the next, exactly like a row of falling dominoes. We are tracing this power journey for the LA5752P architecture, following the electricity from the charger jack all the way to the CPU core. Logically tracing this sequence identifies the specific unfallen domino where the chain reaction stops, removing the guesswork of testing random capacitors or chips. The starting point is the input circuitry near the DC in jack. The adapter voltage, known as VN, enters the board and creates a primary power line labeled B+. This is the main power rail for the entire motherboard and the absolute prerequisite for everything else. If B+ is missing, the fault is located backward in the input circuitry. If it's present and stable, the first stage is successful and we move forward. Next, B+ generates the always-on standby power rails, measured as +3 VLW and +5 VLW. These rails remain active even when the laptop is physically powered off. They sit in a standby state, waiting to detect a signal from the power button. While the schematic mentions a main PW on signal for these rails, there is no easy test point for it. Measure the output coils for 3 and 5 volts directly to verify this stage. Finding these standby voltages confirms the motherboard has successfully primed its baseline power and is ready for user input. This standby power routes directly to the embedded controller, or EC. Think of it as the board's primary brain that wakes up before anything else. Pressing the physical power button commands the EC to broadcast the SUSON master wake-up signal to the rest of the board. To verify the SUSON signal fired, we check for the creation of the +1.5 volt power rail. The +1.5 volt rail powers the DDR3 RAM, providing an accessible test point on the motherboard to confirm the EC is responding. If this 1.5 volt rail is missing, you must investigate the embedded controller to see if it's receiving the button press or failing to send the wake-up command. Detecting this voltage proves the power management logic is successfully translating your physical button press into system-system electrical commands. We now reach the final checkpoint, delivering operating voltage to the CPU core. The expert shortcut here is locating the VR on signal within the CPU voltage regulator module section. VR on is the final command in the chain. It authorizes the voltage regulator to actually power the processor. When all previous voltages are present but the CPU remains unpowered, checking VR on pinpoints the exact break in the sequence. If VR on is present but the CPU voltage is missing, you have isolated the fault to the VRM hardware, avoiding a misdiagnosis of the entire motherboard. Let's recap the chain. Then creates B+. B+ creates the 3 volt and 5 volt standby rails. The standby rails wake the EC, which sends SUSON to create 1.5 volts for the RAM, finally leading to VR on powering the CPU. Following this chronological roadmap allows any technician to pinpoint the exact failure on a dead LA5752P board without relying on luck. This sequence solves the no power problem. But what happens if the entire power chain completes and the screen still remains black? That requires the no display diagnostic blueprint. Click the next video to see the solution.